Hey everyone, my name is Arnold AJ. This will be a video for the Computing Technology Project A. I'll be taking you through our blockchain based password manager and the progress we have made so far. Before that, we acknowledge the traditional owners of the land and pay our respect to their elders past, present, and emerging. Through this video, we aim to give you an understanding about the progress we have made so far. I will be introducing the project and describing our main objectives, while the rest of the team will guide you through the architecture and the technical aspects of our project. We all use the traditional password managers on a day-to-day basis. They are convenient, but they come with major security risks. Since all the passwords are stored in a central location, a single breach can compromise millions of users' passwords. Users also have very little control over their data as they are reliant on third-party providers to manage their sensitive information securely. Our project addresses these concerns by shifting to a decentralized blockchain-based model that gives the users back the control of their credentials. So a secure decentralized blockchain-based password manager. For our project, we have decided to use the Solana blockchain for its speed and cost reasons. To protect sensitive information, we are implementing SHA-254 encryption and bcrypt for hashing. Authentication relies on public-private key pairs, putting full control in the hands of the user. Finally, the system is built with a React.js frontend, making it very intuitive and accessible. Together, these components create a powerful yet user-friendly password manager designed to keep user credentials safe and accessible. Now I'll hand over to Taruka to take us through the architecture.
Thanks, Arnold. Our architecture begins with a web application built in using React.js. This provides user with a responsive interface to manage their passwords. To connect our application to the blockchain, we have integrated Web3 Solana library. Think of Web3 as a bridge between users' action on the app and the blockchain. Anytime a user interacts with the app, like saving or retrieving a password, Web3 securely translates those actions into the blockchain requests. These requests are then sent through RPC Endpoint API. This RPC Endpoint API acts as a gateway, allowing our web application to communicate with the blockchain almost like a regular web server. On the blockchain side, we have something called deployed contract. This is our smart contract that is responsible for securely storing and managing passwords. Once the Web3 sends a request, this deployed contract receives it and can securely add, retrieve, or update password data as needed. Now, smart contract doesn't start off as an active part of the blockchain. It begins as a code which then compiled into the bytecode. Once the bytecode is deployed, it becomes our deployed contract, capable of executing secure transactions on the blockchain. To sum up, the flow of architecture starts with the user's actions in the React frontend and goes through the Web3 Solana library, travels via RPC endpoint API, and reaches the deployed smart contract on the blockchain. This decentralized design ensures that the data is both secure and tamper-resistant. Up next, Joshua will take us through the blockchain section. Over to you, Joshua.
Thank you, Tharuka.
Solana is a high-performance blockchain platform that combines a unique proof of history with a proof-of-stake consensus mechanism to deliver a fast and scalable decentralized network. It supports decentralized applications and smart contracts, making it a versatile choice for developers. In Solana, all data is organized into what are referred to as accounts. Accounts are records on the blockchain that hold data. These include executable programs such as smart contracts or program states such as user data. Each account is identifiable by its unique 32-byte address that can store up to 10 megabytes of data. In the Solana ecosystem, smart contracts are referred to as programs. These programs are deployed on the blockchain by storing them in on-chain accounts and contain executable code organized into functions known as instructions. These instructions define the operational logic and behavior of the contract. These may include instructions for storing, updating, and deleting passwords in our application. PDAs in Solana are a special type of account used to securely manage data on the blockchain. They are generated and controlled by a smart contract with no private key, making them accessible only via the program that created them. In our password manager, PDAs act as individual vaults for each user's credentials, enhancing security by isolating user data. In practice, the user connects their wallet to sign transactions that interact with the Solana blockchain. Each transaction must include the address of the smart contract, the accounts involved in the transaction, and a byte array that indicates the specific functions to invoke from the smart contract, along with the necessary data, such as an encrypted password.
Over to you, Vanuja.
Hi all, I'm Vanuja. So I'll be demonstrating on how our product implementation works. So at first, the user has to log into the website using the master password, which is hashed in bcrypt and it's stored in the database. So then the user has to log in with the wallet's credentials to authenticate the user furthermore. After that, upon successful login, the wallet address is stored into the database. Then when the user saves a new password, the system generates an encryption key from the master password. Then it's stored in the memory temporarily. After that, the password is encrypted and stored in the blockchain. Then at last, when the user retrieves the password, the application retrieves the encrypted password from the blockchain. Then the system derives an encryption key and use it to decrypt the stored password. That's all for me. So I'll be handing over to Ross to justify the architecture and cost analysis. Thank you.
Thanks, Vanuja. So, as you all know, selecting an appropriate blockchain in this architecture is really important. So, why are we using Solana blockchain here? First and foremost reason will be that Solana is really cost effective, and as you can see here in these tables, we have multiple blockchains like Ethereum, Polygon, Binance Smart Chain, and Tezos. And when we compare all this, Solana has the lowest cost than any other blockchain, which is $0.0001 to $0.001 as our read cost and $0.001 to $0.004 as our write cost. Now, what is read cost and write cost? So basically, when a user stores their password in the blockchain, it's a read cost, and when user fetches the password from the blockchain, it's a write cost. So approximately, when we count around 250 passwords per user, the approx cost will be 0.275 to $1.25 per user. So now let's see what are the advantages of Solana other than its cost. Solana provides high performance by handling hundreds of transactions per second. That means it allows faster processing speed than many other blockchains. Also, the smart contract that we use for Solana is created using Rust, which is a powerful programming language that helps in executing logic on the blockchain in secure and effective manner. So these are the answers for why we are using Solana blockchain. And now I would like to hand over to Shweta to talk about our team's journey in this phase one of the project.
Thank you, Rose. Hello, I'm here to share some reflections on our team's journey in developing a decentralized application with blockchain integration. Our project was both challenging and rewarding, and we relied on an agile methodology to stay organized. By breaking down each objective into manageable tasks, we maintained steady progress and made necessary adjustments during regular meetings. Communication was essential both within our team and with our client to keep us aligned with our goals. One of our biggest challenges was a skill gap in blockchain development, especially with Solana integration. To bridge this gap, we dedicated time to research and compared Solana to Ethereum, which helped us design a custom architecture suited to our needs. This experience underscored the importance of adaptability and being open to learning as we went. Delegating tasks based on each team member's strengths allows us to work efficiently and maintain high standards. Early sprint planning also ensured we could tackle unexpected issues without losing momentum. We documented each phase of development, creating a valuable reference for future sprints. Ultimately, this project wasn't only about technical achievements, it was about building resilience and collaboration skills that we are confident will benefit us in the future projects. A strong sense of unity within the team made a huge difference facing obstacles together. We supported each other, turning challenges into growth opportunities. Thank you for listening.